Alright, this is part 2 of section 12.4. We left off with finding the IQ with a z-score of negative 1.5. Percentiles and quartiles. First talk about percentiles. If n% of the items in a distribution are less than a particular data item, we say the data item is in the nth percentile. In other words, if I have 57% of all data items below the one I'm looking at, we would say it's in the 57th percentile. If I have 90% below the data item, we would say it's in the 90th percentile. Quartiles are very similar, but instead of doing like 100%, 1, 2, 3, 4, 5, we go by 25s. So the 25th percentile is the same as the first quartile. Remember quarters, 4 quarters in a dollar. Quart refers to 4. So there's 4 quartiles. The first quartile is the bottom 25%. The second quartile, we add another 25%, so it's the bottom 50%. The third quartile is the bottom 75%, and then the fourth quartile would be basically 100%, if you will. Using the z-score in a table. There is a table in your book on page 719, I believe. And it's going to give you the percentile, which is the data items, the percent of data items that are less than what we're looking at. So in the table, it's going to give you a z-score and it's going to give you a percent or decimal. So you first find the z-score, you look it up in the table, and that will give you percent, and that will be the percentile or the percent less than what we're looking at. Normal distribution, mean, median, mode, corresponding z-score of 0, 50th percentile. What that means is 50% of the data items are greater, 50% are less than the mean, the median, and the mode. Cholesterol levels, normally distributed. For men between 18 and 24, the mean is 178.2. Standard deviation is 40.7. What percentage of men have a cholesterol level less than 239.15? So, first thing you have to do is find the z-score. Find the z-score, you look it up in the table that's in your book, and the table will tell you the percent less than that data item. And so remember the formula for z-score. Data item subtract the mean divided by the standard deviation. So this is our data item. This is what we're trying to figure out the z-score for. And we have a mean and we have a standard deviation. So we plug those into our formula and we get a z-score of 1.5. Once you get a z-score, you're going to look at the table on page, I believe it's 719. Could be 720, I don't remember, but it's one of those pages. So this is a portion of that table. Okay. So we look for our z-score, which is 1.5. It'll give us our percentile, and this tells us the percent that are going to be less than the data item that we got the z-score for. So 93.32% of all men have cholesterol level less than that data item that we were looking at. So first thing you need to do is find the z-score. Second thing, use the table to find the percentile. And if we're trying to find the percentage between two data items, then we're going to take the larger percentile and subtract the smaller one. So larger, subtract the smaller percentile if we're trying to find the percentage of data items between. Amount of time self-employed Americans work each week is normally distributed, mean of 44.6 and a standard deviation of 14.4. What percentage of self-employed individuals work between 37.4 and 80.6? So we need a z-score for this one. We need a z-score for this one. Those are two data items. So z-score for 37.4. And then you need to find the z-score for 80.6. Once you find the z-scores, you're going to look it up in the table. You're going to get two percentiles. And you're going to subtract the two percentiles. So first thing, we need a z-score for 37.4. A z-score is going to be negative 0.5. We need a z-score for 80.6. That's going to be 2.5. We're going to take these two z-scores and look them up in the table in the book, which will give us two percentiles. So the percentile for negative 0.5 is 30.85 from the table in the book. And the percentile for 2.5 is 99.38. Now, to find the percent between, we take the larger percent, subtract the smaller percent. So 99.38 subtract the 30.85. And we get 68.53. So 68.53% of self-employed Americans work between 37.4 and 80.6 hours per week. Not a bad idea to write this down. I highly recommend it so you'll have it in your notes. If we want to find the percentage of data items less, we find the z-score and we look it up in the percent. That's what we got. That's what we need. If we want to find the percentage of data items between, we find the z-score for both of them, find the percentiles for both of them, and subtract. Take the larger percent, subtract the smaller one. Now we didn't talk about what happens if we want percentage of items greater than. Percentage of items greater than, find the z-score, look it up in the table, but then you have to subtract that from 100. So you would do 100, subtract that percentile that you found. Percent. E-N-T-I-L-E, running out of room. But anyway, so take 100, subtract the percentile. Margins of error, we're going to talk about the formula for margin of error. Formula is plus or minus 1 divided by the square root of n. N is the sample size. And there's a 95% probability that it's going to lie within 1 over the square root of n of the true population statistic. In other words, we're 95% certain that the sample represents the population with a slight error. And this is the error called the margin of error. Random sample. 17% of the children said getting bossed around is a bad thing. Verify the margin of error. So, the margin of error, we are going to take plus or minus 1 over the square root of n, where n is the sample size. In other words, how many people were asked in the sample. So the sample is how many children we talked to. So 1172. You would calculate that on a calculator. And you would say, so you would get plus or minus 2.9%. So what does that mean? 95% probability that the actual population is going to be 2.9% above the 17% and 2.9% below the 17%. So you got to add the 2.9% to the 17 and get 19.9 right here. And then you're going to take 17 and subtract the 2.9 and get 14.1. So for the margin of error, you have to add it to the 17 and you have to subtract it from the 17. There are different kinds of distributions. This is a normal distribution, but it is skewed. Notice it has a longer tail on the right. Because it has a longer tail on the right, we say it is skewed to the right. If you have a tail on the left, we would say it's skewed to the left. The homework is 8 through 96, but when you look at the homework assignment, there's a graph on page 727, and it looks like the graph is for number 8, when in fact it's not. The graph is actually for number 16, which is on the next page. So be very careful when you're doing the homework assignment not to try to use the graph for number 8. It's not for number 8. It's actually for number 16.